Welcome folks. In this video we are going to look at question 2 of mathematics paper 2 for the year 2023, and this is the paper that was written by the external candidate. So let's look at this question 2a in a geometric progression. So we have a GP, the second term is given, which is 21, and the fourth term is 189. Calculate the first term and the common ratio. We want to find the term on the first position and the number by which the terms were multiplied to have the second term. Now we'll begin by first making a sequence. First term is not given, so say T1. Then second term is given, which is 21. Then the third term is not given. Fourth term is given, which is 189. Now, how can we find the first term? Now, we are going to use at least 3 ways in which we can find this question. So let's begin first by finding by using this principle. Now this principle, make sure that whenever you are trying to use this principle, you need to make sure that the only number that is missing in between the two numbers is 1. We are going to consider 21 as A, comma, then B we don't have, C we have 189. Now, how can we find the middle number between two consecutive terms? I mean, between 3 consecutive terms. So this is what we call a geometric mean. Under arithmetic mean, the concept is you add, then you find the average of 2 numbers. But for this one, if we are looking for the middle term, we just have to multiply A, this value, times this value, which is C. Then we find the square root of the product. B is equal to, what is the value of A? So the value of A is 21, which is the first number. 21 multiplied by the value of C is 189. Okay. 21 times 189 will give us a 3,969. Then we are going to find the square root of this number. The square root of this number is 63. This is our middle term. So this is the number on this position. Now, if we are able to have 3 consecutive terms, we can find the common ratio. Now, how can we find the common ratio? Common ratio is given by second term divided by first term, or third term divided by second term, or fourth term divided by third term. Now, since we have the third term, we have it. So we'll say third term is 61. I mean, this should be 63, not 61. So easy, 63 over 21. 63 divided by 21 is 3. This is our common ratio. This means that they were multiplying by 3. 21, if you multiply 21 times 3, you get 63. Times 3, you get 189. Now, how can we find the first term? So if going forward is done by multiplication of a whole number, then moving backward, the reverse is you need to divide, because the reverse of multiplication is division. So for us to find the first term, which is A, we are just going to divide 21 divided by 3. So here we have our A. So our answer is A, first term is equal to 7, common ratio is equal to 3. Now, let's find another method in which we can solve the same question. So do the same. First term we don't have, Second term we have it. Third term we don't have. Fourth term we have that number. So here we are going to use the method where we are going to form two equations. Remember, for you to use these two equations, you need to use the geometric NF formula. That is what we are supposed to use. So the formula is Tn is equal to A times R raised to the power n minus 1. So let's find first the equation for the second term. So for the second term, here, where there is Tn, you substitute the number of that position. So since on the second position we have 21, where there is Tn, we put 21 is equal to A, we don't have, then times R, we don't have, N is the number of terms, which is 2 minus 1. Remember, second term, that's where the value of 2 is coming from, which is 21 is equal to A raised to the power n minus, which is 1 minus 1 is 1. So this is equation 1. Let's form equation 2. So equation 2 still Tn is equal to A times R n minus 1. Then where there is Tn, we are going to substitute with 189. First term we don't have R. Now for this equation is the one with the fourth term. So where there is n, we put 1 minus 4 minus 1, which is 189 is equal to A times R raised to the power 3. Okay, so this is equation 2. Now we need to see if we can break 89 into two numbers, so that we see if we can have the common 21. So now for us to do this, we are going to divide. So we'll divide a 189 divided by 21. We have this 21 for the other equation is equal to 9. So 189 is same as 9 times 21. I've just broken the 189 into two numbers by making sure that there should be this number must be common to this number. So since now we know that where there is 21 is equal to AR, so we are going to substitute 9 is equal to, here we put AR, then is equal to AR cubed. 9 times AR is 9 AR is equal to 9 R cubed. Now since we are solving for common ratio and the first term, let's divide by AR, also here by AR. So if we cancel this, we have 9 is equal to this AR, this A cancel, then this R cancel, we have R squared. Let's take the square root, also here the square root, which is R is equal to 3. We are still getting the same answer as this one. That is our common ratio. Then we know that for us to find the 121 times 3 will give us the 3. 21 divided by 7, by 3 we have 7 as our first term. Now let's see if we can do the same. So let's find the same values by using another method. Now for this one, we'll just consider the first, the two given terms. So the numbers, the first term we don't have, the second term we have it, 21. Then the third term we don't have, the fourth term we have it, 189. Now what we are going to do is, let's just focus on the two given terms, which is 21, comma. Now whenever you are trying to use this method, the first number in between those two numbers that you are given, the first number must be considered regardless of the position. You need to take it as the first term. So we are going to assume this is term number 1. Okay, so let's say this is our term number 1, term number 2, term number 3. So we use Tn. Tn is equal to AR n minus 1. Where there is Tn, you substitute with the last number. So the last number is 189. A is the first number, which is 21. Then here we are going to have n raised to the power. How many terms do we have? 1, 2, 3. So 3 minus 1. So here we are going to divide with 21. Also here with 21. So that if we cancel, we have r raised to the power 2. Since 3 minus 1 is 2, then we are going to divide 189 divided by 29, meaning 21 is 9. Then we take the square root, also here the square root. R is equal to 3. So you know that if you are able to get the ratio, you can find the the previous or the one in front. So here is 63, here is 7. So this is how we can find a question like this one. Okay, so we move on to Roman number 2, where we want to find the 60th term. So first term is 7, second term 21, third term 63, fourth term 189. So the pattern is we are multiplying by 3. So first term, second term, third term, fourth term, fifth, 60th. So we can find the 60th term by just multiplying the number by 3. 189 times 3 is giving me 567. Multiply again. So 567 times 3, I'm getting 1701. So this is our 60th term. Or if you want, we can use the formula Tn is equal to A times R raised to the power n minus 1. So Tn of how many terms? So Tn 60th, it means we are dealing with 6 terms. So where there is n, we put 6. A, we have the first number, which is 7, ratio 3 raised to the power 6 minus 1. T6 is equal. Now please do not multiply 3 by 7. No, first you need to expand 3 raised to the power 6 minus 1 on its own. So 3 raised to the power 6 minus 1 is 5. Tn is equal to 7 times 3 raised to the power 5. I'm getting 243. Then lastly, we multiply by 7. So I'm getting 1701. So it's the same answer. Now we move on to some of the first 5 terms of the progression. So sum would be A, open brackets, n, not n, r raised to the power n minus 1 over r minus 1 whenever a common ratio is greater than 1. So this is the formula that you're supposed to use. Now sum of how many? 5 terms. So the 5 terms is up to this number. So if you want, before you use the formula, let's add these numbers. So the sum is just the total in terms of addition of the given number. So since we are dealing with the 5 terms, we can add 7 plus 21 plus 63 plus 189 plus 567, I'm getting the sum of 847. So this is the number that we want. Now let's use the formula. A is 7. Common ratio is still 3 raised to the power 5, since we are dealing with the 5 terms. So 7, 3 raised to the power 5. So we have 243 minus 1 over, it should be 1, over 3 minus 1 is 2. Then we are going to have 7, 243 minus 1 is 242 over 2. So 242 times 7 divided by 2. I'm getting the same answer, 847. So the sum, what they wanted was 7 plus 21 plus this number plus this number plus this number. So these are 5 terms that they were looking for. Okay, so now we move on to question B. Given that matrix P is equal to 7x minus 2, negative x, positive 1, find the value of x for which the determinant of P is negative 10. How do we find the value of missing letter given the determinant? So first we need to identify the major diagonals. This is our major diagonal. Then we are also going to look at the minor one. So we have our minor diagonal. After you identify that, then you can proceed by looking at the determinant. So we have the determinant is denoted by these symbols. The determinant of matrix P will be the product of this times this, so 7x times 1, always minus, then the minor will be this times this, so it's negative x times negative 2. Now remember, where there is determinant, we are going to substitute with the value of negative 10, since it's given. Negative 10 is equal to 7x times 1 is 7x minus negative times negative is positive, times the negative outside the bracket still negative. X times 2 will have 2x. 7x minus 2x is 5x over 5 over x is equal to negative 2. Now let's find the actual matrix for P. So we have 7 times negative 2 minus 2, negative 1 times negative 2 plus 1. The actual matrix P is equal to 7 times negative 2 is negative 14, negative 2. Negative 1 times negative 2 will give us positive 2, 1. So this is our actual matrix. Now we can proceed by finding the inverse of matrix P. So matrix P in terms of the inverse is equal to 1 over determinant times the adjoint of matrix P. 1 over the determinant is negative 10. So we can now find the adjoint. The adjoint of a matrix, you interchange the position of the major diagonal. This simply means that this 14 will go where there is 1, then the 1. So the major diagonal, you just have to interchange the position. 1 goes there, negative 14 comes here. Then for the minor diagonal, you just have to change the signs. Positive 2 will change into negative 2. Negative 2 will change into positive 2. So here we have 1, 2, negative 2, negative 14. This is our final answer. So this is what I just wanted to have a discussion on. That's it for this video. Thanks for watching.